So, see, I will not get into cone penetration test details now. Okay, cone penetration test I should explain you first. Then only you should be able to understand. So SPT I will explain in another one class. Okay, SPT I will explain the separate test. I will explain in another one class. Okay. Now going forward, you see I'll again go back to the code and I'll explain another one or two points related to code which we have already discussed. Okay. So see, so this part we have discussed, this part we have discussed, relative density of soil. Everyone can see it, relative density of
Yes,
soil.
sir.
Yes. So see, what is a cohesionless soil? There was a discussion. There was a doubt that cohesionless soil means whenever there will be a cohesionless soil, code is also saying, you see, cohesionless soil means C should be equal to 0. So if you want to find out the ultimate net bearing capacity for a cohesionless soil, so in case of a purely sandy soil, what you can do, you can calculate based on this 5.2.1 and 5.2.2. So please understand, whatever till now we have discussed, whatever we have discussed, that is 5.2.1 and 5.2.2, that means 5.2.1, this is basically based on the relative density of soil. So based on relative density of soil, you can decide on general shear failure, local shear failure, or interpolation between general shear failure and local shear failure. So this 5.2.1 clause will be valid in case the soil is cohesionless only. That you should remember. So if it is a cohesive soil, you cannot apply this relative density formulation. Okay, you cannot apply this relative density concept. So if it is a cohesionless soil, then only you go for it. Okay, and the second part, you see the chart whatever I have shown you just few minutes back, that is the standard penetration value versus your standard penetration value versus your angle of internal friction, and another one axis, the what is the type of the soil, that is the loose, dense, or very dense. So you see that clause is also valid. That means this 5.2.2 will be also valid in case the soil is cohesionless. That means if the soil does not possess any cohesion, then only you should be able to apply, or you should be able to use this chart. That means if the soil is cohesionless only, then only you will be using this chart. Are you getting? If it is a cohesive soil, then you cannot use it. So for a cohesive soil, you will have to use some other method. Okay. So if it is a cohesionless soil, then you see what the Indian Standard Code is saying. It is saying the standard penetration resistance shall be determined as per IS 2131 1981. And what is the process for determining the standard penetration resistance value, that is given in the code. In a separate class I will discuss it. Okay, and you see it is saying that in computing the average at the end, if you see, in computing the average, any individual value more than 50% greater than the average shall be neglected, but the values for all loose seams shall be included. Okay, so this point you should remember, and the point why I am insisting this point, do not use this based on standard penetration resistance value. Do not find out the angle of internal resistance if the soil is not a purely sandy soil. If the soil possesses some kind of cohesion, then you please do not use this chart. This is valid for a purely sandy soil. If the soil is a C5 kind of soil, then you please do not use this chart. Okay. Now next is, you see, the ultimate net bearing capacity shall be calculated from following formula. And what is this? This ultimate net bearing capacity, you see, this is exactly the same whatever we have discussed. So in this, you see, CNC term has been removed. Why the CNC term is not there in this? Can anyone tell? See, in this formula, is there any CNC kind of term? See, if you see this,
No, sir.
if you see this term is just omitted. CNC, SC, DC, IC term is omitted. You notice in this, is it there? CNC, SC, DC, IC.
कोहेशन लेस ऑयल इसलिए
सर
Yes,
सी तो
yeah,
जीरो है तो जीरो हो
yes,
जाएगा.
yes, you have got it. You have got it then. Correct. So that is why, see, what I have told you earlier also. See, everything is coming from basics of Terzaghi, isn't it? Everything is coming from basics of Terzaghi. So whatever Terzaghi's bearing capacity formulation, if you understand it clearly, Indian Standard Code formulation is almost following the same, with some more assumptions introduced into it using Meyerhoff's formulation. Okay. So you see, this 5.2.2.1, you need not to remember this formula. See what is happening, if C is 0, then C and C term will be automatically coming 0. So that's what the code is saying. Okay. Now you see the next part that is given as 5.2.3, that method based on static cone penetration test. I will not discuss this. I will not discuss this now, because I need to give you some idea about standard cone penetration test first to discuss this point. Later on I'll take some time and I'll discuss it. Okay. Then you see, if a soil is purely cohesive soil, you see what the code is saying. What the code is saying, you remember at the very beginning when we were discussing about bearing capacity factor, I told you that you should remember for phi is equal to 0, what are the values of NC, NQ, N gamma? Tell me, what are the values of NC, NQ, N gamma for phi is equal to 0? Anyone?
सर एनसी 5.7 एनक्यू एंड एन गामा 1
Correct. NC is given as 5.7. Correct. So see, that's what Terzaghi has said, I think 5.7. Let me go back to Terzaghi and just let's see. That's what we have seen. So Terzaghi has said NC value will be 5.70, NQ will be 1, N gamma will be equal to 1. And you come to Indian Standard Code. Okay. So if you go to Indian Standard Code, you will notice, do I have it in the this table in PPT, Indian Standard Code bearing capacity factor values? I don't think, no. So let's say, so if you go to Indian Standard Code value, so let me go back again to table number 1. So you see what Indian Standard Code is saying. So see, Terzaghi has said this is 5.7, whereas you observe for phi is equal to 0, Indian Standard Code is saying the value of NC as 5.14. So you must remember these differences. Okay. So if you are applying Terzaghi's, if you are asked to find out the bearing capacity using Terzaghi's bearing capacity formula, then you should use value is equal to 5.7, whereas if you are asked to find out using Indian Standard Code, the value of NC should be equal to 5.14 in case of a purely cohesive soil. A purely cohesive soil means the angle of internal friction is equal to 0, and that's what the code is simplifying the formula at the bottom. If you see, again I go back to that. So you see what the code is saying for cohesive soil. You see, this is for cohesive soil. So code is saying for cohesive soil, see what will happen for cohesive soil. For cohesive soil, your phi is going to be equal to 0, right? So when the phi is equal to 0, your NC value is going to remain, NQ, N gamma values are going to be 1, and in that case the net ultimate bearing capacity, you see, the net ultimate bearing capacity, why the net ultimate bearing capacity it is said? See, the ultimate bearing capacity or the net ultimate bearing capacity, whatever you take, for a cohesive soil where the phi is equal to 0, it is going to remain same, because you must understand and remember the difference between ultimate bearing capacity and net ultimate bearing capacity. You see, in case of net ultimate bearing capacity, what you are doing, you are just subtracting the value of gamma d, right? So in this case, you see, in this case only the portion of the C will be remaining in the equation, and that is going to give you the net ultimate bearing capacity of soil. Okay. So you see, the net ultimate bearing capacity thus for a purely cohesive soil when the phi is equal to 0 will be given as, see, only with these values C, NC, SC, DC, IC. Is it clear to everyone, or do you have any doubt? If you have doubt, please tell. Any doubt? Okay. So see, so I think with this part, let us finish our Indian Standard Code discussion, because you see, this is your standard penetration test, and then it has explained about this chart for static cone test, which we will discuss later. And you see, after that there is not much details which is to be discussed. You don't have it in your syllabus, and this much thing if you understand, from the code, then your understanding should be enough for this semester. Okay. So with this understanding, at the end I will discuss the last slide. See, this part I am not discussing. This is related to sea soil, that is that static cone penetration resistance. I will discuss static cone penetration test separately, then I will again come back and discuss this portion. Okay. But at the final slide for bearing capacity, you see, this is your shallow foundation, and this, what it should be there, what you should be using for a layered soil. What do you mean by layered soil? See, we are till now discussing about the bearing capacities, considering the soil will be possessing similar shearing strength parameters, that is C and phi will be remaining same, because you see, in the bearing capacity equation, what is there? C is there, and phi is coming from the part that the bearing capacity factors are dependent on phi. However, you see, in many cases you will observe, a footing will be constructed, a footing. So this is a footing, you see, this is a footing which is constructed in a soil, and you see the zone of influence. You remember the zone of influence, where there is a triangle being triangular wedge shaped zone is just below the footing layer when we have discussed about Terzaghis bearing capacity formulation. So the zone of influence exactly will be going to a depth B, which is the breadth of the footing below the base of the footing. So you see, if the soil layer is a mixed kind of layer, you see, in this the zone of influence is up to B. However, you see, with this line you can observe that there is a layer 1 of soil. So this layer 1 is having some kind of property. So it is having, let's say, some C and some phi, and layer 2 is having some different C and different phi. So if you want to calculate bearing capacity in such case, then how will you calculate? So that you should understand. Okay. So you see, in that case, what you should do, you should consider two cases. The first case is, if the layer 1 is weaker than layer 2, what does it mean? This layer 1, the shearing strength capacity of layer 1 is lesser than shearing strength capacity of layer 2. So if it is lesser than layer 1 is weaker than layer 2, that means layer 2 is a stronger layer, then in that case design using parameters of layer 1. You got it? So if layer 1, let's say the layer 1 phi value is 30 degree and layer 2 phi value is 42 degree. Okay, so considering that, which is going to possess more shearing strength? Layer 1 is obviously going to possess less shearing strength, and layer 2 will be possessing more shearing strength, because what is the value of shearing strength? Shearing strength is nothing but tau is equal to C plus sigma tan phi. So when phi is more, then layer 1 having lesser phi will be having less shearing strength, and layer 2 will be having more value of phi will be having more shearing strength. So in that case, what will happen? This layer 1 will be considered as a weaker layer, and if the layer 1, that means the upper layer, if it is a weaker layer and the lower layer is a stronger layer, in that case what you will have to do, you calculate the bearing capacity value using the shearing strength parameters of the weaker layer. And in this case, the example I have taken, I have told you what will be the bearing capacity, what will be the shear strength parameter you should be considering. You should be considering the value of phi as phi is equal to 30 degree. Okay, so once you have phi is equal to 30 degree, you calculate according to phi is equal to 30 degree, whatever method of bearing capacity calculation is there, you apply that and find it out. Now you see the second case is the layer 1 is stronger than layer 2. So what does it mean? Let's say now the layer 1 is having value of angle of internal friction as 40 degree and layer 2 is having value of internal friction as 30 degree. So what does it mean? The layer 1 is stronger and layer 2 is weaker. So if the layer 1 is stronger, then how do you compute? So in that case, if you remember the consolidation theory, where the load is distributed in a trapezoidal manner, at a slope of 2:1, okay, so 2 vertical to 1 horizontal or 1 horizontal to 2 vertical, okay. In that case, what you'll have to do, you'll have to distribute the stresses to layer 2 by 2:1 method and check the bearing capacity at this level. Okay, so what you'll have to do, you will have to first find out how much bearing capacity will be getting at this junction layer. Okay, and at this junction layer, after finding out the bearing capacity, also check the bearing capacity of original foundation level using the parameters of the layer. So you distribute the stress. So how do you distribute? Let's say at this base of the footing, you get some bearing capacity value. So let's say at the base of the footing you get let's say 30 kilonewton per meter square. Okay, bearing capacity value, just assume. Okay, so if you have the area of the footing, if you multiply with the area, you know how much is the total load, that footing can maximum carry. Now once you determine that, what you do, you distribute, that means you go down and in a trapezoidal load distribution pattern, you distribute the load and you come to a layer where the second layer is starting. So up to that you distribute it, and then with that area you divide how much is the stress coming because of the load coming at this layer. So once you have found out that, you use the minimum value of the above two. Okay, so this is what actually the codal provisions or different researches given for multiple layers of soil. This is little bit complex to understand, looks to be, but if you do it your hand in your calculation, then you will see it is very simple. Now the third method, which is very simple to do, that is called approximate method. So approximate method, what it does it like this, that use the weighted average value for shear strength parameters. So what does it mean? See, if the layer 1 is having the shear strength parameter as C1 and phi 1, and the layer 2 is having the shear strength parameter as C2 and phi 2, forget about the stronger layer and weaker layer. What you can do, you can just take and weighted average of the values of the layers. So how do you calculate weighted average? You find out what is the depth of the layer. So let's say the first layer is having depth h1 and the second layer is having depth h2. So once you know the depth of the layers, so you can calculate the average value of cohesion and average value of angle of internal friction. So you notice here the average value of cohesion will be given as C1 H1 plus C2 H2. If you have multiple layers, then C3 H3, C4 H4, C5 H5 divided by H1 plus H2 plus H3. This is nothing but weighted average. Okay. However, you notice exactly the same way when we have calculated the mobilized friction. You see, we haven't calculated phi m is equal to 2/3 phi. So in this case also, when you will be using approximate method, at that time also you will have to find out the average value of tan phi. Okay. So tan phi average value you should be calculating using tan phi 1 into h1 plus tan phi 2 into h2 plus tan phi 3 into h3 divided by h1 plus h2 plus h3. So you understood? So see, you need not to think about this thing. You need not to think about these two cases, case 1 and case 2. Okay. See, case 1 whatever we have discussed is very simple. If layer 1 is weaker, then you take what? You just take the layer 1's value and calculate. However, layer 1 if it is stronger, that means if upper layer is stronger and the lower layer is weaker, then you need to distribute the stresses at this level. So there is one method of calculation by this case 1 and case 2. Otherwise, for simple calculation, when you get multiple layers of soil up to which the zone of influence of the footing will be going, so in such case you can just use the approximate method, and in this approximate method it is nothing but to calculate the average or weighted average for cohesion value and weighted average for angle of internal friction value. And after you calculate the value of weighted average for cohesion and weighted average for angle of internal friction, you find out using those values the bearing capacity value. Is it clear? So is there any doubt till this point?
Sir,
Yes.
and sir, can we use approximate method instead of case 1 and case 2?
Yes, you can use. That is what I am saying. Instead of case 1, case 2, see, case 1, case 2, you see, it's easy to use when there are two layers. But if there are multiple layers coming, in case of within this B only, let's say you have multiple layers. Okay, let's say you have one layer over here, right? Then you have, let's say, another one layer over here. Then you have another one layer over here. Another one layer over here. Then what you will do? So let's say this one is layer 1, this one is layer 2, this one is layer 3, this one is layer 4. If you want to do using this case 2 formulation, then it will become very complex, isn't it? However, instead of using this
Yes.
case 2 methodology, you can directly go for approximate method. And in this approximate method, what you have to do? See, for the layer 1, if it is C1 phi 1, then for layer 2 this is C2 phi 2, layer 3 this is C3 phi 3, layer 4 this is C3 phi 4, and the height of the layers are h1, h2, h3, h4. That means what I am saying, the height of the layer. So that means from here to here it is h1, right? From here to here it is h2, from here to here it is h2, sorry, h2. Then from, let's say, from
Yes, sir. Now it is clear, sir.
clear, so here to here it is h3. So what you can do, c1 h1, c2 h2, c3 h3. Similarly, don't do phi 1 h1, phi 2 h2, phi 3 h3, that will be wrong. Okay, what you have to do, tan phi average equal to tan phi 1 h1 you have to do, always you remember. So whenever you will be taking the angle of internal friction, add a tan before it, before calculating the weighted average. Okay, so I think now you have understood. So total Indian Standard Code, complete Indian Standard Code formulation we have discussed. Okay, so till this point if you have any doubt you ask, otherwise we can conclude today's class. Then we'll discuss, as we have said, that in one class from now onwards, in one class we will be discussing problems, and in one class we will be discussing new theoretical concepts, right? So new theoretical concept means we will start with consolidation, next chapter. Okay, so do you have any doubt till this point? Have you tried solving the problem yesterday I have given? Hello,
Yes, sir.
have you tried? So is it okay? Yesterday's problem, I think I have given you the angle of internal friction as 42 degree, right?
Yes, sir.
And I have given it is a circular footing, correct?
Yes, sir.
And what I said, I asked you to do it, solve it using Indian Standard Code. Okay, so please remember it is not Terzaghi. So you will have to follow this 6-4, this recommendation, and accordingly you will have to solve the problem. So you should follow 6403 recommendation. So it is a circular footing. So if it is a circular footing, then what will happen? If it is a circular footing, then you will have to use shape factors, right? So what are the shape factors?
Yes.
Shape factors for circular
1.2
footing?
and 0.6.
1.2. This is
Point
the
two.
this is circular footing according to 1.3 for SC, for SQ it is 1.2, and for S gamma it is 0.6. Okay, so these factors you will have to use in the problem. Okay, and also you notice there is another one twist, another one trick you will have to apply, that I have explained yesterday, that the angle of internal
Interpolation.
and yes, interpolation, very good. So angle of internal friction, if you see, I have given you in the problem, that is 42 degrees. So it is coming in between here. Okay, so it will clear your concept. So it is coming between 40 and 45. So you will have to interpolate the value between 40 and 45 and find out what is the value at 42 degree, right? And for 42 degree value, what are the values of NC, NQ, N gamma? You will have to find out and then put it into equation. And as the problem is given for 42 degree, so 42 degree, you see 42 degree is more than 36 degree, so it is a general shear failure problem. So it is a general shear failure problem. So you consider it as a general shear failure problem and solve it. Okay. Is there any doubt?
Yes, sir.
Anything else? Anything you want to ask? So everyone is clear? Yes, bolo.
Sir, in this problem, if there will be a effect of water table, then what will be the limit of influence?
Yes, if there is a water table, right? If I give a problem with water table, just same thing, same problem, or little bit changing that problem, I will give it in after this today's class. Okay, maybe tomorrow I will give it. Okay, see, if
Yes.
the water table is coming, you see it is again simple. I will go back, you go back to this. So if the water table is coming, so what you will have to do, if the water table is coming, you should use this one, right? So Indian Standard Code formulation you are using, right? So CNC, SC, IC, DC, then gamma, D, NQ minus 1, S gamma, D gamma, and then you see here you have the value of W dash, okay? This W dash, and what I said you, what I told you, this W dash is nothing but your Rw1. You see, this W dash is factor is multiplied with what? This half of B. And you see, if you go back to our formulation, let's go to the water table formulation. Where is it? Water table, this one. So see, this water table formulation, you see, where you have multiplied this Rw2. Rw2 is multiplied with this B, right? 0.5 B gamma B n gamma, with that Rw2 is multiplied. So this Rw2, whatever is given over here, this is exactly your this W dash. Is there any doubt? So if water table is coming into picture, you just use the same thing. The code is also saying this, that you interpolate the value. So this is actually this linear interpolation formula. So dW from here, exactly whatever you have understood, one problem in total detail I have discussed you, right? So using this only, you should be applying this Rw2. Now the question you can ask, sir, where this Rw1 has gone in this equation? In this equation there is no Rw1, you notice? There is no W factor right here. So there is no W factor. So what you should do in that case, this Q is what? This Q is what? Q is nothing but gamma D, right? So what you should do for this portion of the soil, for the soil above this portion, that means for the soil above the base of the footing, that means for the soil up to the depth df, what you can do, you can exactly use the value of the unit weight of soil. That means if the soil is submerged, then use the submerged unit weight of soil. If the soil is saturated, then use saturated unit weight of soil. If the soil is half submerged and half saturated, then you take weighted average of it and then you can apply. Or if you want to avoid everything, then what you do? You just use this Rw1 factor. Because this Rw1 factor, you see, this Rw1 factor is nothing but it takes care about the change of the unit weight of soil due to the effect of water table. So what I suggest you, when you will be applying this formulation for Indian Standard Code, you just use the same idea whatever you have understood for this water table correction for bearing capacity. Okay, is it clear? Any doubt?
Yes, sir.
Okay.
Yes, sir.
Okay. So should I let us stop today? Okay. And in the next class we will start with consolidation. Okay.
Okay, sir.
So
Yes, sir.
one class will speak about consolidation and more problems we will discuss. I need to give you more problems also. Okay, for bearing capacity. See, you please go through the PDF I have shared with you. Okay, very good problems are there. See, this problem you don't try. This 16.2, example number 16.2, whatever I have given here, whatever is given over here, please don't try. Okay, I will. No, 16.2 you try to understand. Okay, 16.2 you try to understand your own. Only this problem, this 16.3, you leave it. Okay, 16.3 is a mixed mode of failure problem. Okay, so 16.3, this phi, you see, phi is given for 30 degree. You notice, phi is given for 30 degree. Okay, so you see the soil is neither failing by local shear nor failing by general shear. So there are some techniques to be applied for solving this kind of problem, which I want to discuss separately with you. Okay, so see, important, I have written here, important. So we'll discuss this. So there is another one, interpolation will be coming into picture. So you don't try to understand this problem as of now. I will explain it, then only you read it. Okay, then only you try it. Okay, so 16.3 problem you leave it, but other than that, other problems you try your own. Okay, all the problems you should be able to understand. Whatever things we have discussed, all the other problems, whatever is given over here, you should be able to understand. Okay, so I request you, all of you, please go through this, whatever the problems I have shared with you PDF, leaving 16.3 problem. 16.3 problem in a single class I will discuss with you separately. Okay, okay. So let us stop today. And sorry, don't go away. I will take the attendance. Just a minute. So, full attendance collect. enter, 30, download, done, attendance done, print screen, article are there, then I take a word file, then new document create. Okay, so that's all for today's class.